2.9, compute the total number of electrons stored in the material from x is equal to 0 to x is equal to L. Assume the cross-section area of the bar is equal to A. And the example 2.9 mentioned is this one. Okay, that is consider a scenario depicted in figure 2.11 again. Suppose the electron concentration is equal to n at x is equal to 0 and fall linearly to 0 at x is equal to L. Determine the diffusion current, and they use this equation to find the runout. Okay, and the current is constant and all this stuff, but here what we are interested in is the electron stored in this material, the total number of electron stored in the material from x is equal to 0 to x is equal to L. Now let's see how to find that. Now let's redraw this diagram. Here we have a triangle. Okay, and this one is origin, and at the origin we have the height of n, so which means here if we write in terms of x and y, this is 0 and this one is x is 0, y is n, and here the length is L, and if we write this one in terms of x and y, x is L right here and y is 0. Okay, and we can also name this one as x2 y2 and this one as x1 y1. If we do that, and area is given to be A, now we can, based on that, we can create an equation for the slope. So here we can say y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1, and here this y is n of x minus 0, x remains the same, L, instead of y2, now that y2 is n, so we can put that in right here, and then y1 is 0, so we put it right here, and then x2 is 0, we put it right here, and then x1 is L, and from this one we can solve for n of x, and that's going to end up being minus n over L times x minus L. We can furthermore simplify by multiplying this. Let's go and do it in the next page. So from the previous one we derived n of x is equal to minus n over L minus n over L x minus L x minus L. If you multiply this one, this is gonna give us minus nx divided by L, and then minus nl, actually minus this is going to turn into plus, so plus nl divided by L, here nl cancels, so finally we end up getting minus nx over L plus n. Okay, that is what we are having, so let's leave it there like this, good enough to simplify. So this is our n of x value. Now using this we can find out the total electrons stored, find out the total electrons stored. What we do is we integrate with respect to the distance, that is 0 to L in this case, by by the area times the nx, the y value, that's n of x in our case, of x, we integrate this one respect to x. So we know the area is A, so like let's keep it as A. Okay, so they have given area as A, so we keep this one as A, and then n of x, we solve this one with this, So we replace that one with this minus nx over L plus n, and we are integrating with respect to x. So everything except x is going to be a constant. So when we integrate this, only the things with x is going to be affected. So here, if we integrate the first term, that is a, and here this is a constant, so we can also keep it print as well, but let's keep it here. And then minus n, and if you integrate an x, that's x squared divided by 2. So this is going to be minus nx squared divided by 12. And then here, this one we don't have, this is just a 1 we are integrating. So if you integrate 1 with respect to x, that's going to be just x. So nx, that's it. And this one, the limits of integration is 0 to L. 0 to L, below them. So 0 to L, like if you substitute 0 for x, the whole thing is going to be 0. So first we plug the upper limit of integration for the x, and that's going to be x replaced with L. But the lower limit, when we substitute, that's going to make the whole thing 0. So we don't have to worry about the lower limit of lower limit, because it's going to turn to 0 both of them. So the minus part is gone. So only the upper limit plug in right here. So this is going to become minus nl square divided by 2l, and this one is going to become nl, and that's it. And we can simplify this one square and this one cancel. So this is going to be a times minus nl divided by 2, and here we have nl. And if I want to bring it into the same denominator, then I can multiply this one top and bottom by 2. So this is going to become minus nl plus 2nl divided by 2, and here 2nl minus nl, that's going to become nl. So a times nl divided by 2. Okay, and that is our final answer. So we can finally go and write, therefore the total number of electron stored in the material from x is equal to 0 to x is equal to L is a times nl divided by 2. Okay, and this is our final answer. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on